Hi, we shall be discussing today on this video about operation with pointers. We shall be covering an overview of pointers, and then the rest of the video will be covering the different valid operations that can be done within pointers. To start with, when you say pointer, a pointer is a variable that stores the address of another variable. So in the Photoshop, you can see that there is a variable declared A with an initial value of 5, which holds memory address, let's assume 204. Okay, and there's another variable, a pointer variable declared named P, which has been stored in approximately address 64. When P will point into variable A, what happens is that the value of this pointer P would be the address of A, which is equal to 204. Now let's start with the first operation that you can do inside a pointer. First one is what we call as assignment operation. In assignment, you can assign an address to a pointer. Typically, you do this by using an array name or by using the address operator ampersand. For instance, we have this code count of type integer with initial value of 10, and then to declare a pointer, you have to make use of the asterisk symbol before the variable name. So int asterisk pointer, which is PTR. And then, in order for PTR to be able to store the address of count variable, simply type PTR equals ampersand count. So what happens in this declaration is that if you would take a look on the here we go. The variable count is assumingly stored in memory address 300,000 with a value of 10. On the second line, when we declared pointer as pointer variable, what happens is pointer has been allocated or stored approximately in memory address 700,000. And when we start to have the third statement, pointer equals ampersand count, what happens is that pointer is now storing the address of a pointer or of variable count. That's why you can see from the box that we have 300,000 as the value stored in the pointer variable. And when this happens, pointer is also or can access the value stored in the count variable, as you can see. That's how an assignment operator is able to link a pointer variable into any ordinary variable. Here we go for the second operation. The second operation is called dereferencing. When you say dereferencing, it means we get the value that is stored in the memory location pointed to by a particular pointer. The asterisk operator is used to do this and is called the dereferencing operator. For instance, given the same previous example, when I would like to display the value of the count variable, I can do it in two things. One is either to use the variable itself which is cout count. Definitely you will be displaying the value of the variable count, or you make use of the dereferencing operator. So what happens here is that when a pointer variable points a certain variable, now that can be dereferenced through using the asterisk symbol. The second example is another form of what we call dereferencing. Pointer variable is not only pointing to the address of a certain variable, it could also manipulate the value, hence we call it dereferencing. That is, if I have example number 2, asterisk pointer equals 20, it means that we are trying to modify the value of count variable. So from 10, it changes or becomes 20 after this statement. Let's move on. Another operation, valid operation in pointer, is taking a pointer address. Like any ordinary variables, a pointer variable have an address and definitely have a value. Regardless of whether it is a pointer variable or an ordinary variable, two things will always happen. The variable will hold a value and at the same time holds an address in the memory, as shown in the right side of the presentation. First example, cout address of pointer. That is referring to the previous example that we have. So if I say cout address of pointer, what happens is that we are trying to display the address of the pointer itself. Well, the second example is, the second line on example number 1. If we would like to display the address pointed to by the pointer, then we just simply call the PTR or the pointer variable itself. So generally appending the ampersand symbol beside the variable means you are accessing the memory address of that particular variable, no matter whether it is a pointer variable or an ordinary variable. Let's go to example number 2. Okay. Let's assume that there is an array variable of size 5 named earn with an initial value of 100, 200, 300 until 500 respectively. Okay, and we have 3 pointer variables, pointer 1, pointer 2, and pointer 3. If you were to look on its representation in the computer, the array variable will hold 5 different memory locations of type integer. So that means that earn 0 will have approximately an address of 0xFF380. And since this is an integer type of array, what happens is the next address will be plus 4 bytes. That is why it is 0xFF384. And it keeps on adding additional 4 for each memory segment or memory location. So that's why it's 388. Then it goes to 38C, and then finally it reaches to 3F0 for the last index of the array. Let's move on. If we have the statement pointer 1 is equal to earn, what happens is that pointer 1 is trying to point now to the first index of the array itself, or the array variable itself. So that is why the value of pointer 1 now becomes FF380, referring to the first part of the array variable, the address of the first index, while it maintains its own address. Next line is pointer 2 equals ampersand earn index 2. What happens is pointer 2 takes the address of the third index, which is referring to earn 2. So where earn 2, the address is 0f, 0 times ff388, and it says here that pointer 2 now is also storing the same memory address. And when we try to confirm the address of these things, you will come to know that we have mapped it correctly. So let's try to make use of an example to prove our claim. Here we go. The same set of codes, earn 5 with initial value, and then we have assigned pointer 1, 2, and 3. We have pointer 1 pointing to earn, and then pointer 2 pointing to the third index, and then we try to display earn, the address of earn, the address of pointer 1, address pointer 2 by pointer 1 and pointer 2. Here we go. Okay. Address of pointer of earn, the first index is 0x28FEE0. And since pointer 1 is pointing to the first index, so what happens is the address pointed to by pointer 1 is the same with earn. And the address pointed to by pointer 2, which is the third index, is 0 times 28FEE8. That is from 0 to 4 until 8. So we were correct on what we were discussing previously. Let's move on to the next operation, that is adding an integer to a pointer. When you say adding an integer to a pointer, you can use the plus operator to add an integer to a pointer or a pointer to an integer. In either case, the integer is multiplied by the number of bytes in the pointer to type, and the result is added to the original address. Example, pointer 3, using the same set of codes previously shown, pointer 3 is equal to pointer 1 plus 1. And when we display the address of pointer 3, what will happen is that on this line, let's clean this up. Okay. Where are we? Yeah. Pointer 3 is equal to pointer 1 plus 1, where pointer 1 is pointing to 0 times FF380, which means that if you add 1 on the address pointed to by pointer 1, you try to add only one memory segment. So from this point, pointer 3 is pointing now to this particular memory address. Okay, so let's try to prove that one. Which means pointer 2 should be pointing to the next segment, which is equivalent to pointer 3, 0 times 28 FEE4. So we were correct again. Next operation is incrementing a pointer. When I say incrementing a pointer to an array element makes it move to the next element of the array. Simply moves to the next element of the array. For instance, if we have this example, pointer 1 plus plus, where pointer 1 was initially pointing to, let's clean this up, where pointer 1 was initially pointing to 03 times ff3 380, increasing it, or pointer 1 plus plus would point to the next index, which is 0 times ff384. Let's try to prove that. Here we go. So if I activate this example, what will happen is that pointer 1 and pointer 3 is pointing on the same memory address. So, address of pointer 3, which was discussed previously, and address of pointer 1 is now the same. In like manner, if we are adding an integer from pointer, we also have subtracting an integer from pointer. You just simply use the minus operator to subtract an integer from a pointer. The pointer has to be the first operand for a pointer to an integer. For instance, if we have pointer 3 equals pointer 1 minus 1, then that means it will decrease minus 4 bytes to the address pointed to by pointer 1. The same thing goes to decrementing and operate a pointer. It's the opposite of incrementing a pointer. So when you decrement the pointer, what happens is it also decreases to minus 4 bytes, assuming that the pointer pointed to by that pointer is an integer variable. So if you say pointer 1 minus minus, then you subtract minus 4 bytes. If this is an array, that means it moves on the previous memory storage. Next operation is what we call differencing. You can find the difference between two pointers. Normally, you do this for two pointers to elements that are in the same array or variable to find out how far apart the elements are. So if we have an example here, a new example, earn 5 with initial value 100, 200, 300 until 500 respectively, 3 pointers. And when we say pointer 1 is pointing to the first, to the index 1 of earn. Let's clean this up. This is differencing. This is pointer 1 is pointing to the first index 1, sorry, not first index, and pointer 2 is pointing to index 3. And when we do differencing, that is see out pointer 2 minus pointer 1, what happens is that we are trying to get only the number, or how far is the difference between what is pointed by pointer 1 and pointer 2. Let's have an example. Let's try to hide all these things. Okay. Let's assume that we are using the same memory address previously. That index 0 is in memory address times 0. This is 4, this is 8, this is C, and this is F0. So if pointer 1 is pointing to index 1, that means this is 4. And pointer pointing to 3 this is C. And the difference would be simply from this point to this point is 2. Let's try to run. If I run this, the result should be they are 2 blocks away from each other. Last operation for pointers is what we call comparisons. You can use the relational operators to compare the values of 2 pointers, provided that the pointers are of the same type. General truth. Example, using the same example, earn 5 with initial value of 100 to 500 respectively, 3 pointer variables. Pointer 1 is pointing to index 1 and pointer 2 is pointing to index 3. And if we would like to compare, you just simply append the asterisk operator between pointer variables. That means you are comparing the values pointed to by each variable. So if pointer 1 is greater than pointer 2, that's 3. Where pointer 1 is pointing to index 1. This is pointer 1 pointing to 200. The other one is pointing to, pointer 2 is pointing to 400. So what happens is that when, we're not on the same example. Should be here. Here we go. Pointer 1 is pointing to 200, and then pointer 2 is pointing to 400. Value 400. So if we compare, if pointer 1 is greater than pointer 2, is 200 greater than 400? Definitely not. So the result should be pointer 1 is lesser than pointer 2. Or should I say, the value pointed by pointer 1 is lesser than the value pointed by pointer 2. Let's have an example. Let's run this. Okay, and activate this. The answer should be lesser. And when I run this, I should get the result. Pointer 1 is lesser than pointer 2. Then we are correct. Okay, so that ends the discussion of operation with pointers.